Okay, so this this clamp knurling project has three mild steel parts in it. Okay, that means the steel or the carbon content of this steel is low. It's low carbon steel. It doesn't have enough carbon in it that it can be hardened. So if we want these parts to be hard for durability, we have to case harden them. Okay, and case hardening is the process of introducing carbon into the surface of the part at high temperature until the surface of the part has enough carbon in it that it can be hardened. And once that point is reached, then the part is quenched in cold water to harden the part. Okay, so first thing we need to do is we need to add carbon to the surface of these parts, and we do that by a process called packed carburizing. Okay, so you have to buy yourself some case hardening compound. Caseonite is one brand. Cherry Red, I think, is another one. Gunsmithing shops carry it quite frequently. I think I bought this from McMaster Carr. I know they carry it for a fact. All it is a powder. It has a lot of carbon in it. It's probably made out of charcoal and scraps of leather and various stuff that contain carbon. In fact, I think if you don't want to spend the money for it, I think you can probably make it yourself. Just get yourself some charcoal and some pieces of leather and grind it all up into a powder and use it. It might not be quite as efficient as this. You might have to let it set and let it heat for a longer time so the carbon diffuses into the surface. But I think it'll work just fine. But I find it easier just to buy the ready-made stuff. So first thing we need to do is put some of this stuff in. I like to use a box just to help hold everything together. It not only holds the parts together, it also, whenever you do this process inside an airtight container. Okay, and to do that, the reason you do that is if there's oxygen exposed to the parts at high temperature, they oxidize and it makes the surface very rough. So if you want to keep a nice looking part, you have to do it in a low oxygen atmosphere. So what I do is I immerse these things in the powder, okay, and then I either wrap them in paper or, in this case, a cardboard box, and then you put this whole assembly inside a stainless steel envelope and seal it all up. So it's inside a sealed container. And so when you heat it up, then the cardboard or paper or whatever burns and consumes whatever oxygen's inside the envelope. So I happen to have this nifty box here all ready to go. So we'll just put the parts in there. Add the carburizing compound. Make sure you get all the areas coated. These parts are especially important that you get carburizing compound down in the gap here, because this is actually a functional hardness here. We want it to be hard so it doesn't wear against the rotating knurl. Okay, so just make sure everything's nicely coated. And then you need some stainless steel foil. This stuff it's some kind of craft foil I found on Amazon. It's made by K&S Metals. All it is a real thin stainless foil to stand up to the heat of the process. You have to be careful handling this stuff. It's razor sharp. So let's just get this wrapped up. Try and figure out a way to do this without wasting too much. Without bleeding to death. Okay, so we're just going to seal it up in this foil. say be really careful sliding your fingers along this because it really is razor sharp. Yeah, see that? Bleeding already. Like I said, add a little bit more here for good measure just to make sure all the voids are filled in. Okay, fold it all over and that's our package. Okay, now we got to heat this whole thing up to between 15 and 1600 degrees Fahrenheit and let it soak for a while. The longer you let it go, the deeper the carbon layer is going to get. So I like to keep it up to a red heat for about an hour. That'll give us a couple thousandths thickness of hardness on the parts, which will greatly increase the durability of them. So let's see if I missed anything. I don't think so. It's a pretty simple process. Next thing I'm going to show you how to do is how to build a little furnace so we can heat these things up. I mean, if I were to do it myself, I would probably I have a heat treat furnace. I would do it in there. Be the easiest. Or I also have an oxyacetylene torch. I could heat it up with that. But not everybody has those things, so I thought I'd come up with a way to do it with readily available materials. So what I did is I came up with a forced air charcoal furnace made up out of fire brick and a heat gun for the forced air. So I'll show you how to put that together and we'll get this thing started. Okay, so we have our parts all wrapped up in the carburizing compound. Now we need to figure out how to get them hot. They need to be about between 15 and 1600 degrees for 45 minutes or so. So if I were doing that myself, I have an electric heat treat furnace that I would use. It's pretty easy to do, but not everyone has one. So I came up with an alternative method, just a forced air charcoal furnace. Charcoal's the fuel, and I use my trusty Harbor Freight heat gun to fan the flames, so to speak. So I have a bunch of fire brick that I used on hand. I mean, you can buy them locally at Home Depot or any of the local building supplies. If you have a masonry supply in your town, you can probably get them cheaper there. There's two different sizes you can get. You can get the full size ones, or you can get the sort of half size. These are about half price, coincidentally. So if you can use some of these in place of the big ones, you'll save yourself a few bucks. Like for the base here to build the thing on, you can use these thin ones, all right? Or you can just use, this doesn't get very hot, so you can just use a piece of steel plate or aluminum plate to build your furnace up on. So let's go ahead and set the thing up. I'll show you how I did it. I've tried a few different methods here, and this one seems to work out the best. So let's build it up. First thing, like I said, to lay out just a base to build the thing up on. Then we need to make like an air chamber underneath the charcoal to provide forced air to the charcoal. So what I would do is just take a couple of fire brick, make them about the same size or same distance apart as the nozzle on the heat gun. Okay, then we'll just expand it out a little bit and build the fire pot back here. We want as much air to get to the charcoal as possible, so let's build this out like so. Alright, so that makes a nice shot of air into the area underneath the charcoal. And to keep the charcoal up off the bottom of the air port or air chamber, we'll just put a piece of expanded metal on it. And then we'll continue to add to it here. Like so. Okay, so now we got a nice pot up here to fill up with charcoal for fuel. We have our screen at the bottom of it, and we have an air chamber underneath to sort of provide forced air to the charcoal so it burns extra hot. Without the forced air, it doesn't get nearly hot enough to heat up all these steel pieces we're trying to harden here. So you gotta have the forced air. And we'll just close off the chamber a little bit here so we can set the heat gun in it, like so. And that's all there is to the furnace. Other than, well, we have a couple more brick to top the thing off, like so. So the idea here is to fill this fire pot up right to the top with charcoal, lay our parts to the front here, and then we'll put these brick on top to seal off the back part of it and leave a small vent right up front. So the forced air goes into the chamber underneath, up through the charcoal, kind of swirls around and comes out the front here. And if you place your parts right up here near the front of the chamber, all those hot gases are going to go right by it on their way out through this vent. It gets pretty darn hot. I played around with the vent a little bit. It looks like if you make it about the same area as the input, maybe a little bit less, works out pretty well. If you get it too big, then you just waste a lot of heat. If you get it too narrow, you don't get enough flow or enough air to the charcoal to make it burn hot. So it's kind of a balancing act. But like that works pretty well. So let's start up a load of charcoal here. Just going to use a chimney starter. Takes about half a chimney starter to get the thing going. Trying to get too much lit up here, just waste it. It's going to take, like I said, this thing has to go for 45 minutes or so. It's going to take probably 15 or 20 minutes to get the thing up to temp. So it's going to take, you're going to have to replace the charcoal or add the charcoal probably 2 or 3 times throughout the process. But I'll show you how to do that when the time comes. So let me get some matches and get this thing started. So let's get this thing fired up and do some heat treating. Alright, we'll let that go for a while until the charcoal gets started, then we'll pour it into the fire pot, add our parts, and turn on the air. It'll probably take 15-20 minutes, so I'll be back then. You guys just stand here and watch it. Okay, charcoal is going pretty well now. Let's get the show going here. said, we'll stick the parts up to the front here. And put our bricks on top to keep the heat in. And start some air here. You don't have to use the heat, just all we need is just the forced air. Right, you can see the smoke coming out of our vent here. As the charcoal burns down a little bit, it'll seal up better. And things will start getting hot. The first batch, pretty much most of the heat goes into the brick. Okay, you got to heat the whole furnace up first, so it doesn't really accomplish much. The second one you put in, when you fill it up the first time, you'll really start getting the part hot. And then of course the third one the same way. It'll take about 3 batches of charcoal to get these parts up to that required temperature for 45 minutes or so. Okay, it's been about a half an hour. Seemed like it was taking a little longer to heat up than it should, so I replaced the top blocks with full-size fire brick. I think those thin ones were letting too much heat out, but it's starting to warm up. I think it's a good time to probably add some more charcoal. It's burned down pretty good already. So let's get the parts out of the way. And stir this up a little bit to get any ash dropped down in so it doesn't plug up the grate. You can see the draft coming up through it. That's close enough. It won't take long to burn down. Get it covered up before we lose all our heat. Alright, let that go for a while. Should heat up pretty good now. It's fire brick are pretty much saturated, so heat from now on in will go into the part. That should warm up nicely. So let's let that go for a while. Okay, now it's cooking. This is, I don't know if you can see the flames, but this is what it should look like when it's at peak efficiency. You got flames coming out. It's making sort of a dull roaring noise. I don't know if you can hear that. Let me get the mic a little closer. But it's definitely cranking up the BTUs now. So that'll probably burn easily another 20 minutes or a half hour. And that part, I guarantee if you can, I don't know if you guys can see in there, but it's red hot inside. And that part's probably red hot too. So it's soaking up the carbon. So I want to keep it at that temperature for at least 45 minutes. So I'll let this batch burn down, and then I'll add one more batch and then we'll open it up and quench it. Hopefully we'll have nice hard parts. Okay, I think we're good to go. I think we've got a pretty good case on this thing. It's been like that for about an hour now. That's probably about 1500 degrees or so. And 1500 degrees in an hour should give us about at least 10 thousandths of case on the part. Obviously, there's no hurry in this. The longer you go, the deeper the case will get. In fact, I was looking up some of the temperatures. If you keep it at about 1600 degrees for 4 hours, you get a 60 thousandths deep case. That's a lot of hard metal on the outside of a part. We don't need that much. 10-15 thousandths is plenty, and that's what we'll end up with on here. So now it's time to quench the part. We're done with our case, our carburizing. The part's got probably, like I say, 10-15 thousandths of high carbon layer on the surface. So now, while it's nice and orange red like this, you want to open up the envelope, take the parts out and quench them. You want to keep them hot until they hit the water. So I'm going to leave it right in the furnace. We'll just shut the air off. Okay, so now we'll open this up and we'll just leave it set right in the furnace so it stays nice and hot. And we'll see how I can get this thing open. This stainless stuff gets pretty brittle after it's cooked for this long, so it should open right up. In fact, it is opened up already. That's generally not a good thing, but we'll see how the parts turn out. The whole idea of putting them in that thing was to keep them from oxidizing. It looks like it burned a hole in the thing, so we'll see how they look. Okay, here's one. I'm going to get it right in the water and swirl it around. Okay, there's one. Here's the other one. You don't just want to drop them in the water and let them set. You want to swirl them around. The idea is to cool it down as quickly as possible. You'll get the most hardness that way. Okay. Now, we'll see what these look like. I'm kind of disappointed that bag opened up, but that's the way it goes. Drop that one, but I think you got plenty of quench. All right, so let's see what we ended up with here. Yeah, I think it'll, a little bit of scale on it, but not too bad. I think it'll clean up okay. Let's see how hard it is. Okay, hard as the file. Should be about Rockwell 50, 55, somewhere in there. File won't cut it. So I think we're good. Take a wire brush to it and clean it up and see what it looks like. So that's case hardening in your front yard or your backyard, whatever, without a furnace. Just to review a little bit, this took 3 batches of charcoal. Just be sure the first one doesn't really do anything other than heat the furnace up, so you won't notice a whole lot going on. The second and third batches got nice and hot, so each one of those lasted about a half an hour, so we've got about an hour soak on this part. Should give it a nice deep hard surface on it. So that's about it. Hope it all works out for you like it did for me. See you next time.